Hi everyone. Today we are going to solve a question related to electrostatics. In this question, it is given that an electric dipole with dipole moment 4 into 10 to the power 9 coulomb into meter is aligned at 30 degree with direction of a uniform electric field of magnitude 5 into 10 to the power 4 Newton per coulomb. Calculate the magnitude of the torque acting on the dipole. So first of all, we have to identify that what the things are given in the question. Then we are going to proceed further for the further calculations. So in the question it is given that the magnitude of the dipole moment is P equals to 4 into 10 to the power minus of 9 coulomb into meters. Now the uniform electric field, the magnitude of the uniform electric field is also given. Electric field E. The magnitude of the electric field is given as 5 into 10 to the power 4 Newton per coulomb. And the angle between the direction of dipole moment and the direction of electric field is given as theta equals to, it is 30 degree. Now we have to find out the torque acting on that dipole. We can draw it like, let us suppose this is the electric field E vector and this is the dipole moment P vector, and the angle between them is theta equals to 30 degree. Now as we know that the torque acting on dipole is tau equals to Pe sin theta. As we know that in the vector form tau is P cross E vector. When we take its magnitude form, it is Pe sin theta, where theta is the angle between P vector and E vector. Now all the things are given, so we can put them into the equation. P is 4 into 10 to the power minus 9 into the value of E is 5 into 10 to the power 4, and sin theta is sin 30 degree. Now don't forget to write the unit of tau, which is Newton into meter. Now if you calculate this, it will be tau equals to 4 into 5, which is 20, into 10 raised to the power minus 9 plus 4, and sin 30 degree is half, and the unit Newton into meter. Now if you calculate this, 9 minus 9 plus 4, it is minus 5, and if we divide 20 by 2, it is 10. So we will get tau equals to 10 into 10 to the power minus 5 Newton into meter. Tau equals to 10 to the power minus 4 Newton into meters. So this is the torque acting on that dipole.